Other than that, I don't see any other difference between running it in your own infrastructure or cloud-based infrastructure.
And how easy to add more, for example, disk space or memory in the cloud compared to the local infrastructure we have? I mean, is it so easy to add more disk space or even simulate users, for example, in the cloud?
Simulating users, anyway, you need to do. It's a job of the the simulation software which you are using. Other than that, if you use infrastructure provider, infrastructure as a service, the sophistication of the tools which they have, you would not have. The seamless addition of the resources and the simulation of whole thing would be more, the bleeding edge if you go for infrastructure as a service like Amazon.
Actually, the simulation and testing and load testing, we have done a lot. Actually, we run our own service, so we need to make sure that we scale to a lot of users who are going to use the service. So we have written our own simulation tools, so which simulates we just fire up one instance of Amazon EC2 and run a simulation software which can actually simulate thousands of users per instance, and it gives requests to our service and make sure that how much scalability we can squeeze out of one small instance or one large instance or one extra large instance. So for example, how to add more memory or more disk space and everything, you have lots of different instance types in EC2. So it starts with the small instance, which actually gives you 1.2 gigahertz of processing power and 1.7 gigs of memory, I believe, with around 160 GB of storage. So you can add more EBS storage to the same instance, or you can go for other instance types. There are high memory instance types. There are high CPU instance types, which have little bit of low memory type. There are quadruple memory and quadruple CPU instances also available. And if you want to really simulate the real-time load, you can also go with different region transfers. Like you can run your server in US East Coast region, and you can run your simulation tools in US West Coast or in the EU region and try to simulate real-time users. So those kinds of possibilities are also available in cloud.
Thanks.
Yep. Just to add on that question you had on private cloud, to quote Werner Vogels, the CTO of Amazon, there's no such thing as private cloud. When you mean cloud, which is a public cloud, the scale at which the cloud operates is actually unimaginable. You're talking about thousands and thousands of servers and the ability to add infrastructure just in time. That is something, it's unimaginable from a private cloud point of view. If you're looking at, I have, I've purchased 50 servers which I operate in my premises, and I want to optimally use it. Maybe you can put a virtualization layer and then, optimally use it. But then beyond that, how far you would go to, kind of expand your capacity and then, serve as much as requests, that's where private cloud stops. So a private cloud, there's no such thing as private cloud, and there's a limit there actually. And
Raghu, let me just hold you there for a second. Is everyone aware about what a private cloud is and everything? Because that's a very, like Raghu rightly said, it's a pretty abused term. I mean, just to give a bit of a background, Amazon launched, their cloud platform, and then you had a bunch of companies that came out saying, worry about security, private cloud. There's a company called Parascale that offers a private cloud solution, something called Karingo that does something similar. And then Amazon came out and said, we have a private cloud as well. You can just VPN into our own cloud, and we've got a private cloud. And then Raghu says Amazon doesn't really have a private cloud. So is everyone clear about private cloud? Someone who's not clear along with me can just raise their hand maybe. Okay, we've got a bunch of cloud virtuosos here. So right. Go ahead, Raghu. Just want to make sure everyone was on the same page.
Yep, right. So that's about the private cloud. The question that I asked about testing, right? So that's the advantage of having a cloud in terms of innovating how you want to do your testing. Because when it comes to specifically to AWS, so just like how Jay said, you have a website which you want to do a load testing. So typically you would do some load testing on your own infrastructure and then benchmark and then say this is fine. So now the way you look at your testing and infrastructure changes with cloud. I can simulate loads from different regions, like what happens if my users come from Asia Pacific. So how does my application behave? I'm going to have a server in US. If all my customers are going to come from Singapore, what's going to be the latency? So I can run my testing software in a Singapore instance and then test out the load that is there in the US instance. So then you kind of figure out there's so much of latency. I can re-architect my infrastructure. I will have some servers in Singapore. I will have some servers in the US. And I can use geo-routing software which can kind of route the traffic according to where my users are coming from. So that's the possibility that you're talking about when it comes to cloud. So you can really innovate in terms of what you want to do in the cloud and then come up with the solution that works for you.
And on the private cloud, Amazon actually offers virtual private cloud. It's not actual private cloud.
Just to share our experience on the testing, especially. I mean, we do a Cloud Tesco. Our platform is called Cloud Tesco, where we do a performance engineering. Not all the use cases can be actually hosted on the public cloud, especially if your customer is asking for specific SLAs in terms of your usage. For example, your computing or your network. Because one of the use cases that we got is they wanted us to test a streaming exercise. They have a streaming services that they provide for iPhone and all that devices, right? So they wanted us to test their servers, which is not on the cloud, which is sitting somewhere else. They wanted us to test and make sure, you get this bandwidth that's been initiated from your cloud to the other end. And when we went back to, Amazon and we asked them, can we get a reliable, bandwidth or a dedicated bandwidth for us? They said, no. If you want, you can go for higher instance. You might get, more, or you are, you're going to get more, but we cannot give you a dedicated, So that kind of an SLA, probably you may not be able to do it with your customer. For that, you still need to go for a different service provider, or possibly, you have to run it on your own.
Hi, I'm Karthik. I represent a company called Purple Stream. See, we're working on a TV Anywhere idea. So, in continuation with whatever point you just made, with respect to a dedicated bandwidth available on Amazon platform, we are currently facing challenges with our existing CDNs. Okay, we have placed our co-location servers in close to about 7 servers, which we actually mirror. And ours is typically a live streaming solution, what we offer. Especially in faith broadcasting, you will never be able to predict the kind of audience. And last instance where we have had instances where we had close to about 180,000 concurrent viewers coming in from about 56 countries. So we can see, however you are trying to optimize the current server and the CDN setup, you are definitely going to have some kind of a buffering issues in some part of the world. Okay, so we can't actually really have mirror servers across all the ISPs or whatever. It's virtually impossible. Do you have, what is the solution which you see for our kind of application?
See, one of the most complicated, problem is the CDN. I mean, if you really look at it, serving content is, though we say that, we are very stable in terms of internet and all that, serving content is always a, big problem when it comes to the mass users, right? I would say, the cloud, especially the cloud today, is not ready for this kind of, use cases. You need to still wait. But there are certain use cases that you can, basically employ. Like as I said, live and recorded streaming. Recorded streaming, yes, the cloud provides CDNs via CloudFront. You can actually, create your objects, which could be an RTMP stream over HTTPS on a secured layer. All that you can do with your, and at the back end, as I said, they are using Adobe Flash, servers to basically, serve the content. but it is not meant for live streaming. And live streaming, you have to go on your own. And where Akamai and all the other service providers, where they differentiate is, they give you a mechanism to do live streaming on the edge location.
That's right. What actually we have right now done. So we are right now riding on 7 CDNs.
And cloud does not do that. Cloud do not provide live streaming that can happen from your network to your customers via the edge location. They don't do, and because that requires, as you said, that requires caching, that requires a lot of technical problems that are involved. And in fact, even in the recorded streaming, they had a lot of issues, and they're in fact solving those issues. In terms of deleting an object, you cannot delete. If you want, you cannot delete an object. So they're still, all of them are, is still under the use case. But I don't think your use case can be, solved, especially with cloud from a live streaming perspective.
But any CDN whom I talk to, he says that he has so many mirror servers available in lot many part of the world. But actually, it doesn't solve the problem. In fact, it looks like that we are trying to earn money for the CDN. Ultimately, we pay for the bandwidth, right?
See, if you really look at it, if you take even the YouTube, the mechanism, that they do in terms of, streaming, all that they're doing is a recorded one. So if you can convert your live into a recorded, and in some way that can be, pushed into the CDN, that could be a use case.
Correct. Okay. Currently, what we are doing is whichever country is well behind the GMT, we are following the time zone. Okay. We are focusing everything from Singapore or Japan or Australia, and for US it's always a 12-hour or 10.5-hour deferred. Okay, so we are trying to solve this problem using a playout. Okay. So if an Indian playout, it works out fine, but it will not be fine for every other country. Yeah. So even then we have to take care of the 4.5 hours, which will still be a deficit.
No, I'm saying even the live streaming can be simulated. When I say simulated, like you record now, right, and it's going to get being streamed to the outside world. The platforms like Wobso or your Adobe Flash, servers, what they do is, they get the live stream being, given to the rest of the country, right? So instead, what I would, say, could be the solution might work or, may not work. We can actually, come up with a mechanism in which it will still use your recorded video, and whatever happens here can be recorded, or kept or saved into the cloud as a recorded video. Right, you can come up with some of the flash plays, because I'm sure you might have a portal where you're going to actually do this, right? There, if you really look at it, you can take the advantage of the distribution, the cloud front distribution mechanism. But it requires a little bit of programming, not little bit. You need to really think and come up with some unique solution. And I'm sure that is something used across the the video marketplace like YouTube. And all of them.
No, this is what happens literally in a time shift case scenario. Time shift, if you watch any kind of an Indian television channel which is being broadcasted in US or any country, they have a 10.5 hours or 12-hour deferred. It's basically, these programs are not live.
Yeah, but I think live is simulated. When I say simulated, like if you're watching let's say a game, cricket or something of that sort, right? One TV might show in the same time. That would be 2 or 3 seconds delay in the other TV.
That right? Is because if it's from a DTH, generally what happens is from the Earth station it goes to a satellite, comes back to the aggregation point, okay, and the DTH operator again decodes that signal, right, sends it back to his satellite, yeah, and from there it's a multicast. So I can understand that delay of 3 or 4
that's exactly, that's where I'm coming. I do not know the underlying at the DTH